In this session, we will discuss factory method design pattern. Factory method design pattern was defined by Gang of Four in their famous book, as I talked about in my other presentation. So let's look at the definition of factory method design pattern. Define an interface for creating an object, but let subclass to decide which object to instantiate. Factory method lets class defer instantiation to subclasses. So first of all, the points that we should notice here is that it's all about instantiation. That means it's a creational pattern. And next point to notice is that it involves subclasses. That means there is some sort of inheritance hierarchy involved. That's when factory method design pattern comes into play. And third point that we should notice is the name itself, factory method. That means there's a method which is a factory. So with this understanding, let's take a closer look at the definition. Provide an interface for creating an object. So here it does not mean to provide a Java interface. Okay. So what it means is to create a method or a contract that will create an object. But the class that has that method or a contract does not know what exactly to create because varying requirements. Only the subclasses, the specific implementations will know what exactly to create. So let the subclass decide what exact object to create. So we are kind of adding polymorphic behavior to creation, which is not possible in Java. In Java, constructors are not polymorphic, right? So we are trying to achieve some sort of pseudo polymorphism by letting the subclass decide what to create. So this factory method is also known as virtual constructor. So with this information, let's take a quick example and see the problems in it and see the design principles that it violates, and then see how factory method design pattern will fix it. So first let's see the requirement. The requirement is to provide a batch processor that will process fixed length records. So at the time of design, all information that we had in our hand is to handle fixed length records, which is like take a text file. To process text files, get records, put them into database, write summary, and end of the batch process, right? So that's the requirement that we have in hand, and we forgot to make a flexible design, which means which can be easily changed later on. So let's see how we implemented our initial say sort of bad design. Okay, so here is the batch processor which has to process the batch. So we're going to say public void process batch with the given file name. So what it has to do, it has to create a text parser which will parse the file, create records, and process them. So first step is to open the file. So file equals open file name. Next step is to create a parser that will parse the file. So we're going to say text parser equals new text parser of file, and then we say parser dot parse. That's what we need to do. And when it parses, we need to get a list of records back from it. And then we need to process records. We write some sort of summary, and then we close the file. And that's the end of our implementation. So this is the library that we are creating for processing batch files. So let's one by one provide all the required implementations. Create method close file, system out closed file. Good. Let's go to write summary. System out wrote summary, wrote batch summary. Let's say it's like 0 failed or whatever. Now process records. So we're going to say system out processing db calls q. That's it. We're processing each record. Now we need to define the class called record. Create class records. Sorry, not records. I want to rename it as record. That was a bad name. So let's just change it here. So nothing much there. We created it. Now we need to import Java util list. That's good. Text parser. We don't have a. We create class text parser. We need to create a constructor as well as a parse method. So let's do that here. So we have a public text parser. This takes file argument and does nothing much. Let's just say creating text parser, and it has to provide the public list of records parse. And it says okay, parsing text and creating record list, and let it return the record. So I'm returning null here because we are not really bothered about the actual implementation. We are trying to demonstrate. There we go. So our batch processor is ready except for this. Let's create that method as well. So here also I don't really care about the implementation. Let's just say opened file. So the batch processor library or the framework is ready, and we tested it out and everything is working fine. So we create a final application that can be run from command line, for example, and give it out to the client. Say app, which is a public static void main, takes command line arguments, and let's say batch processor equals new batch processor dot process batch of say args of 0. The first argument we are going to pass file name and let it process that as part of, and let's just say done. That's it. So our app is ready. So now let's see how it behaves. Just really doing a quick run. So I built it. Now let's go to command line. We need to pass command line arguments. So we're going to say java patterns dot factory method dot app, and it needs an argument. Let's say input file, some input file. Okay, open file, creating text parser, parsing text, processing each record, wrote batch summary, 0 failed, close file, done. Perfect. Our batch is working fine and our customer is happy. Everything's running smooth. So the customer comes back to us saying, hey, your batch processor is really doing good job. We need to have a capability to parse and process comma separated value files. Okay, so we jump into action. We go back here and then we realize, oh, okay, I cannot really parse comma separated files right now. So I need a parser. Okay, so let's create a parser. So again, in my batch processing logic, I need to add some sort of a parameter to indicate what kind of file is coming in. So I need to add another argument, string format. Okay, I got the format. Now I need to have creation of parser based on that format. So I'm going to first, create a variable called parser and assign it to null because I don't know what parser to create yet. So I'm going to say if format equals text. If it is a text format, I'm going to say parser equal to new text parser of file. Otherwise, else if format dot equals comma separated value CSV, which is a very popular value, very popular format in batch. We create a parser for that. Parser equal to new say CSV parser. So we don't have a class yet, but I just named it like that. So we are going to again be also, so that we have minimal impact to the existing code, I'm going to just extend CSV parser from text parser so that rest of the code just works fine. Okay, so I'm going to say CSV parser, create class CSV parser. Okay, created CSV parser. Add an empty constructor here, public text parser. Okay, CSV parser, and here we provide the logic to generate CSV tokens and create records from it. So we need to create implementation override the parse method of the parsers. So we say override methods parse, and I don't want to do the super implementation which is parsing text file. Here I want to parsing CSV values and then return the list, returning null because we don't care about the implementation right now. So now let's okay, so we introduced a new argument to our process batch API as format. So let's add it here in the app and say args of 1, which is second argument from command line as the format for this example. So once this is done, let's compile this. Alright, so with this info, let's run it. So some input file of text, okay, it's doing text parsing and creating records and processing that batch. Very good. So let's say we are dealing with some CSV input and then CSV. So open file generally created CSV parser parsing CSV. Perfect. So our batch processor is supporting both these formats right now. Very good. So the customer comes back after a few weeks and tells us your batch processor should support XML at this point, and here is the schema. So again, our programmers go in here and go through the code, and let's assume that this is a very complex batch processing logic right here. And you know, those poor fellows have to go through this logic and understand what happens, where exactly to make a change. So they go here and say, okay, let me add it here. Else if format equals XML, I'm going to create parser equals new XML parser of file. All right, nice. So I can just create an XML parser of file, and let's say system out println created XML parser, and we need to override the parse API so that we parse actual XML, override methods, and we provide the implementation here, system out parsing XML and creating records, and we return the records. So now everything's intact. Let's compile this and run. And see what happens. So CSV is working fine, text input is working fine, and we now support XML as well. XML parser parsing XML and creating records, etc. It's working fine. So as we can see, every change in that requirement of parser or the file type, we are having to come and touch the complex logic of our batch processing, and you know, with the potential chances of introducing unknown bugs, especially if the guys dealing with the library does not know much about the implementations, right? So here we are clearly violating one of the basic object-oriented design principle called open close principle. So open close principle is basically it states a class should be open for extension and closed for modifications. So if you look at this modification standpoint, we are modifying the class, and causing unknown issues here in this class. So we are clearly violating that design principle, open close, which is always known as the OCP, open close principle. And violating OCP will introduce bugs, and especially if you are designing a library or a framework, you might end up breaking a lot of different clients, and you don't want to go back and touch your main classes all the time, right? So that is one violation. Another thing is your high-level class, which is a batch processor, is depending on real concrete classes. So this is another violation of design principle called dependency inversion, where which basically says you should always depend on abstractions. The high-level abstractions should always depend on abstractions only, not in concrete classes. So by violating this principle, what the end result is that we are breaking the flexibility of our implementation. Okay, so and it's the design is not robust. So what we have to do is, this is the place where factory method comes into play and saves the day. So first thing that we have to do is that in factory method, it's dealing with the creation, right? So what are we creating here? The parser. So now let's see, let's provide a factory method to create parser. So what we are going to do is that when I'm designing my batch processor, I'm just thinking that I might have to support, say, 100 different formats, but I don't know what are the formats right now, right? So what I'm going to do is I'm going to just get rid of all these things, right? And then I'm going to say, okay, I'm going to have a parser, which is like an interface for parser. Which does the parsing. So public list of records parse. So all it does is defining this API, the parser. So each implementation has to provide that. So we'll come back to it later. So the parser, okay. So we said, okay, we are going to have a parser. Now let's, the parser, we don't know what parser it is. So we say create parser. So this is the factory method that we are creating. Okay. So the class knows, okay, I need to create a parser, but I don't know what kind of parser it is. So the class defines it as an abstract method. Okay. So we're going to say now the class becomes abstract. So the class has become abstract, and we have the create parser, which is the factory method. So now let's see how a subclass will create the exact parser it needs and how things will go. So now we define our framework class, which is this. This is the library which is built, and we are never going to touch this class whenever the requirement changes. And probably we don't even need the format because we are not using any decision making based on format here, right? So this is the API. So now we'll go, let me change a little bit here. There we go. Parser, parser. This is the factory method. Now, okay, so let's see the requirements. We need to support, say, initially we need to support the text file. So we already have a text parser. So it needs to implement our parser interface. All right, it already does the implementation. So we're good. So we are going to create a class called text batch processor, which extends batch processor. So text batch processor is the subclass of batch processor. Now this text batch processor will decide what to create for parser. So it's going to create new text parser. signature has a little problem. So create parser with the file name, or say file. So we need to make sure that we provide that everywhere. Okay, text batch processor takes a file argument. Okay, return new text parser with file. That's all text batch processor is doing. It's not touching the batch processing logic, which is part of our abstract batch processor. This can be even public final, because nobody can change the core of our batch processing. Okay, so now text batch processor decided we need to create a text parser. Similarly, I need the requirement changed. I need to have CSV support. Okay, fine. I can provide a CSV batch processor which extends batch processor and decides what parser to create. And obviously, we need to create a new CSV parser with the file. That's done. Now we need to have XML support. So we will do XML batch processor extends batch processor and it decides what parser to create. It knows it has to create XML parser. That's it. So app has to change a little bit here, because first of all it's an abstract class, so we don't know what to create. So here app is going to say create create batch processor, or create batch processor with the file. So create batch processor with the argument that indicates what type of batch it is. So args of 1. Now once the batch processor is created, the main has to just do process batch and pass the file name args of 0. So now we need to provide an implementation for this, which is in the app, which is a private static string argument. So here we make that decision which was inside our library earlier. So if arg.equals text return new text batch processor. If argument.equals CSV, I return new CSV batch processor. And if argument equals say XML, I return new XML batch processor, and default I return null because I don't know what to create. So that's it. So we created the required batch processor based on the argument and let it process the batch. So that is the refactoring we did based on the factory method implementation. So now let's see how it looks when you run our example. And so let's compile. So once it's compiled, let's run the XML example. So we got the XML processed properly, good. We got the CSV, very nice. We got the text, that also looked very nice. So that's the implementation of batch processor based on factory method pattern. So what we did is we created an abstract class for batch processor. It provided an interface to create parser. The interface is a contract, create parser, which it did not know what parser to create. So it let the subclasses decide what exactly to create. So that's the implementation of factory method design pattern we got. And if you look at the app here, we added some logic here to create based on the format. Some people kind of misunderstands this as the factory method design pattern. This generally is not considered the factory method design pattern. This is considered as static factory or simple factory because it's not conforming to the gang of four definition of having superclass and the subclass decide what exactly to create, right? So that's all there about factory method design pattern. Basically, the basic thing that you have to keep in mind is that there's a contract and there's a factory method. Basically, a method that is a factory, and the subclasses create the actual implementation. So now let's take a quick look at the class diagram of what we have. So we have this base class that has the creational method, and the subclasses provide the concrete implementations and return the actual implementation for the dependency here. And as you can see, this involves class hierarchies. So when to use this design pattern? If there is an inheritance hierarchy where a polymorphic creation is needed, as we saw, when you are modifying a class to accommodate varying requirements, violating open-closed principle, that is causing a lot of maintenance overheads. And design principle we want to adhere to the design principle of dependency inversion. That factory method design pattern lets you do that. And finally, a quick note about simple factory, which we saw, the static method that creates certain objects based on some conditions. That is sometimes called simple factory or the static factory. For example, calendar.get instance. And I don't think we should confuse that with the factory method design pattern by GOF. So that's all about factory method design pattern. Hope that was clear. Thank you.